Geometry students, in this lesson, you're going to be learning about my favorite isometry and yours, a reflection. In this lesson, what we're going to be doing is learning how to reflect a figure across a line. Okay, and there's some easy reflections and there's some more difficult ones. Let's get started. The first thing we're going to do is just talk about what a reflection is. A reflection, again, is an isometry. What that means is we're not changing the pre-image when we draw the image. It's going to be the same size and shape, but it's going to move from one place to another. In this case, it's going to flip over as well. So we're not going to be able to actually rotate it back so that it perfectly matches the original unless it has something called symmetry. And we're going to talk about that in a future lesson. So kind of keep that word in the back of your mind. But anytime you do a reflection, you flip something from one facing to a different facing. However, it is the same size and shape as the original. And what we're going to talk about is that there's some really easy versions of this. Now, one of the things you're going to see here is that there's a specific notation that we use for transformations. Okay. And there are two really simple type of reflection transformations. One is reflecting across an axis, the other is reflecting across a diagonal line, a perfectly diagonal y equals x line. It's really easy to do that. And then after that, all other reflections are kind of difficult. Okay, they're not prohibitively difficult, but they take some time to figure out. Now let's just take a look. If I'm reflecting a point or a figure across an axis. And what we're going to do is we're going to do this point by point. So we're going to consider that I'm translating the point xy. By the way, this notation is very important, so make sure you take a look at it. Notice we start with a capital T for translation. We're translating a point x comma y. Notice I have this in point notation. It's in parentheses xy. And then I'm going to transform it so that it becomes x negative y. What am I doing? I'm just making the y term negative. That is how you reflect something over across the x-axis. If I'm reflecting across the x-axis, the x value stays the same, and the y value of every point that I reflect becomes its opposite. Okay? For a point reflected across the y-axis, it's just the x changes to its opposite while the y stays the same. That is one of the easiest translations that you, or I'm sorry, translations, transformations that you can do is reflecting across an axis. Another really easy one is reflecting across the line y equals x. Y equals x is a perfectly diagonal line that has a slope of 1 and passes through the origin. To reflect across that line, what you need to do is simply swap y and x. So every point you're just swapping its y value with its x value. And then all other transformations you just got to kind of figure out. And my suggestion is to graph the line, graph the figure, and then you need to think through what it's going to take to translate each of the points across that line. How do you do that? Well, you look at the line, you look at a point that you want to and I think I said translate again. I meant reflect. You look at a point that you need to reflect across the line, okay, to the other side. And what you need to do is measure the distance between that point and the line. We've done this before. In order to do that, you need to find the line perpendicular to the line of reflection, okay? Hey, you know how to find if this line is perpendicular. You need to find a slope that's the opposite inverse of the slope of this line. And then you know how to figure out how to make that line pass through a particular point. You plug in the xy value of that point. And then once you have the line between this point and this line that's perpendicular, what you need to do is figure out where this perpendicular line intersects the original line. Well, you can do that just by setting the equations equal to each other and finding x and then finding y. And then you can calculate the distance between these. Now remember, we learned how to do that in a previous lesson. It was one of the things I said is the probably one of the most complicated things you're going to have to do in geometry, but you know how to do it. And we're just going to take it one step further. Once you find this distance, all you need to do is go that same distance on the other side of the line. Okay, so you need to travel that same distance along the line on the other side, and then you can plot your image point that same distance away on the other side. And that is how you're going to do that. Now, listen, most of the time, these are going to be a lot easier than what I just described. Okay. But I am calling back to something we learned how to do. You did learn how to calculate the distance between a point and a line. You've probably had it come up several times in the homework where you've had to calculate that distance. Now you're going to be called on to maybe do that with reflections and just continue that distance on the other side of the line of reflection and then plot your point at the end of that distance. Most of the time, by graphing, you're able to figure these ones out. Like they'll put the line at such an orientation that it's pretty easy to figure out just by inspecting a graph where this point goes. And that's why I say for all other reflections, you should actually graph the reflection to figure out the relationship. Okay, let's take a look at some problems here. I have A, B, C, D with vertices A11, B 5.51, C 5.5, and D 1, 3.5. I'm supposed to reflect A, B, C, D as described, okay? This says reflect A, B, C, D across the y axis. Now, for number one, if I'm going to put this in my reflection notation, my transformation notation, what I'm going to do is T colon x comma y. Okay, so I'm going to translate each xy coordinate by, and let me just grab one of these arrows here. Okay, by doing what? I'm going to, if I'm reflecting across the y-axis, that means it's going to be negative x, y. Okay, so if I'm translating this across the y-axis, what are my points going to be? I would plot point A at negative 1, 1. Point B at negative 5.51. Point C at negative 5.5, 3.5. And point D at negative 1, 3.5. Notice that the y value stays the same. All I'm doing to translate across the y-axis is making the x coordinate negative. Easy, easy. That one was easy. All right, one quick note. I went back and I changed the markings here so that these are primes because these are actually the image points of the pre-image. So I need that extra notation there. Now for letter B, I went ahead and I plotted some points and a line on here because this is not simply reflecting across an axis like letter A was. Letter A was one of the easy reflections, okay? When I reflect across an axis, all I have to do is make something negative. It's really easy. This is not so easy. I have to reflect across the line y equals 2, which means I'm going to have to graph it out. And I'm just going to use the existing graph down here. I'm not going to use the image that's on here for letter D, but I'm going to use these blue points. These are my pre-image points. Notice I plotted 1, 1, 5.51, 5.53.5, and 1, 3.5. Now, I didn't even have to engage with this in letter A because I knew there was an easy way for me to just reflect these. Now I can see that this figure is actually a rectangle. Okay, these are the four corners of a rectangle. I could connect these with lines. Notice I also graphed the line y equals 2. I'm going to be reflecting across. That's my line of reflection. And I'm just going to notice that that line of reflection passes through the figure. It passes through the rectangle. And what that means is some of my points, my lower points, are going to reflect upward over the line of reflection. And the upper points are going to reflect downward across the line of reflection. Now, if my entire rectangle was on one side of, like, let's say that this line was up here somewhere, then I would reflect the entire rectangle across to the top of that line. But that's not the case. It passes through my figure. So we're going to have to reflect some points up and some points down. Now I'm going to place these black image points where the reflected points are. And to do this, I'm just going to look at my line of reflection and look at each of my pre-image points. And I'm going to place the image point the same distance on the other side of the line of reflection. So notice that this first pre-image point, this is point A. It's going to go, it's one unit away from the line of reflection. So what do I have to do? I need to make it go 1 unit above, one more unit above the line of reflection for the image point. Same thing for this one. It's one below, so I need the image point to be the same distance away above the line of reflection. Okay. Now this one probably is a little bit high. I'm going to bring it down just a little bit there. There we go. All right. Now this image point we'll use this blue pre-image here. Notice that one's 1.5 units above the line of reflection. So I need to put this one 1.5 units below. There we go. Okay. This was point, I should have labeled my points on here. This is A, B, C, D. Okay. It goes in that order. A, B, C, D. I did not do these in the same order, in alphabetical order here. This one is 1.5 units above. So I need to put it 1.5 units below. And now I have all of my black image points plotted. Now all I need to do is note what their coordinates are. I'm not going to write a transformation statement here because this one's going to be a little hard to write anyway. I could probably figure it out. But let's see. We're going to say that the image of A, that's this point here, is at the same x coordinate. It was at 1 before. It's still at 1 because it reflected over a horizontal line. But now the y coordinate is 3. Okay. B is this one, this pre-image point, this blue one here, reflected up to here. So this is my image point. That's going to be at 5.5, same x coordinate. But now the y coordinate is going to be 3. It's a rectangle. Notice that there's some relationships among the values. This was at 3. This one's at 3. Of course, they're going to be at the same y coordinate because they have to line up with each other across horizontally. So, or I guess you would say vertically. So I could draw a perfectly horizontal line between them, right? All right, let's keep going. C, its image point is going to be, let's see, it was up here, this blue pre-image. Now it's going to be at 5.5. Let's see, it was 1.5 above. Now it's 1.5 below 2. 1.5 below 2 is 0.5. And then D, same situation. D was this point up here. It's going to be at 1, comma 0.5. That's this black image point down here. Okay, so I took those pre-image points, reflected them, and these are the correct image points. Letter C, another easy reflection. Okay, this is one of my 2 easy reflections across the line y equals x. So this is, I'm going to put this one in translation notation. I'm just going to copy my translation notation from above. So it's just T colon, let's see if we can get this right. T colon, that's good enough. X comma Y. But this case, now I'm switching because I'm flipping across the line y equals x. The x is going to become a y and the y is going to become an x. What does that mean for each of my coordinates? Well, that means that A prime is going to be 1 comma 1. Because it's on the line of reflection, it's not going to move. Okay, so if I flip the 1 and the 1 around here, it's the same number anyway. It's not going to matter. B prime is going to be 1 comma 5.5. C prime is going to be 3.5 comma 5.5. Notice I flipped around the x and the y. And then D prime is going to be 3.5 comma 1. And I could easily graph those. What I would find is that now my rectangle is standing up on end instead of being flat against the x-axis.